GCSE 9-1 maths, looking at exam style questions, okay, for higher and foundation, the crossover topics, okay, for the algebra section. So solving inequalities, solving a quadratic, solving simultaneous equations in roughly, okay, 7 minutes. Okay, let's go. Okay, question number 18. Yeah, take from an OCR past paper 18AI. Solve 5x plus 1 equals x, sorry, greater than x plus 13. Treat it like an equation. Okay, keep that symbol there. Step 1, I'm going to subtract x on both sides to balance each side of my inequality respectively. 5x take away x will be 4x. So 4x plus 1 is strictly greater than, yeah, or larger than, yeah, or bigger than 13. I'm now going to subtract 1 on both sides. Again, balance each side, yeah, respectively. 4x is strictly greater than 12. I don't want 4x, I just want x is bigger than. So divide by 4, divide by 4. X is greater than 3. And that is my solution to the linear inequality. And that was worth 3 marks. Say 1 mark for each step. Part II, write down the largest integer, so largest whole number that satisfies the inequality 5x minus 1 is less than 10. So step 1, I'm going to add 1 to both sides. I get 5x is less than 11. Divide by 5 here on both sides. We're going to get x is less than 11 fifths, which as a decimal, okay, will be 2.2. So x is less than 2.2 or 2 1/5. Okay. So the smallest whole number that satisfies this inequality, that will be 2. Okay, because when x is 2, that's less than 2.2. X cannot be equal to 3 because 3 is bigger than 2.2. So the largest integer that satisfies this linear inequality is x equals 2. 5 times 2 is 10. 10 minus 1 is 9. 9 is less than 10. Therefore, that is true. Okay, that statement or claim is true. Part B, solve 3x squared equals 75. So divide by 3 here, first step. We have x squared equals to 25. Now, at this stage, okay, I've got 1 or 2 options. I could subtract 25 and then factorize here using the difference of 2 squares, or I can just do the root of both sides, including my signage, okay? So the opposite of square here, that'll be square root, obviously square root. So x equals plus or minus the square root of 25, which simplifies to 5. So plus or minus 5, because a quadratic has 2 distinct real solutions in general at GCSE level, okay? So if it's x squared equals a number, then x equals plus or minus the square root of that number, okay? So, so divide by 3, yeah, and then obviously root both sides, okay, or square root both sides. When I do that, these obviously just cancel because they're inverse operations. So x equals plus or minus the square root of 25, which is plus or minus 5, okay, because 5 squared is 25, okay, and minus 5 squared, okay, on minus 5 here, also here equals 25. Part C, so solve a pair of similarity of equations, okay, equations. 4x plus 3y equals 5, 2x plus 3y equals 1. Label it equation 1 and equation 2. Now, because here my y's are the same and the same signs, I can do equation 1, subtract equation 2, so 1 take away 2, 1 minus 2, okay? When I do this, 4x minus 2x makes 2x, 3y minus 3y goes to 0, okay? Hence here, the elimination equals 5 minus 1, which makes 4. So x equals 4 divided by 2, okay? So, yeah, divided by 2 on both sides. So 4 divided by 2 is 2. So x equals 2. So if x equals 2, guys, I can now substitute x equals 3 and into equation 1, equation 2, okay, to work out what y is. Doesn't really matter. I'm going to put it in 2 because it's slightly more easier algebraically. Doesn't make much of a difference. I'm going to have 2 times 2, so 2 lots of 2. 2x means 2 times x. So 2 times 2 plus 3y is equal to 1. 2 times 2 makes 4, so we got 4 plus 3y equals 1. Subtract 4 on both sides and then divide by 3. Okay. So we have 3y is equal to minus 3. I don't want 3y, I just want y. 3y means 3 times y. So dividing it by 3 on both sides. So divide by 3 here, divide by 3. You have 3y over 3 equals minus 3 over 3. So y is equal to minus 1 or negative 1. And that is my solution to the pair of simultaneous equations. Again, okay, for higher foundation. Okay, the key with this or with this topic is that you want to make the signs of the letters here the same and have here the same number. Okay, if that makes sense. So if the signs are the same and the same number, then you subtract the equations. If the signs are different and it's the same number, okay, in front of the that coefficient of x or y, then you add both equations here to obviously eliminate it. Okay, but that's how we solve a pair of similarity equations here. Okay, for part C. And again, each of these questions here is almost a hot topic here that will appear, okay, on an examination here. So revise here solving linear inequalities, okay, revise here solving quadratics, and revise solving a pair of simultaneous equations for GCSE 9 to 1 maths. Okay, but this is also appropriate revision for anyone here that is doing AS pure maths or GCSE level 2 further maths. Okay, but this is ideal for foundation higher for GCSE 9 to 1 maths. Okay, but that's it for me today, guys. Okay, thanks for watching. Like, subscribe, share. Okay, follow me on YouTube, share, follow me on TikTok. Okay, save the video, subscribe, like, reshare, repost. Okay, put it in your WhatsApp group here, put it on your Facebook groups here, put it on your Twitter groups, okay, and help me reach 10k followers so TikTok can finally pay me some penny coins, okay. But help me reach 10k followers by the 31st of October if possible, and I'll see you inside the next video. Okay, bye for now. Take care. All the best.